today's topic is such an important one that is a real milestone for this program and something that anyone who wants to do hypertrophy training needs to learn about, obviously. And understanding the science of hypertrophy will really help you to be able to reach your full potential with your hypertrophy training. And it's something that I've really been anticipating, and as you can see, I went to all the trouble of drawing these special diagrams for you, which are probably harder to do than it looks. Okay, drawing a lot of perfect circles that have to be all the exact same sizes actually was quite challenging, and just reminded me that I'm not a visual artist. But I am an artist when it comes to programming. And I'm so excited to be teaching this class, and I know you're probably looking forward to learning about it too, so without any further ado, let's get right into it. Hypertrophy. What is it? Hypertrophy is a growth in size of muscle fibers. And when I say growth in size, I mean mostly the width is growing. And it is one of two modalities that muscle growth occurs. The other is called hyperplasia, and that is the adding of new muscle fiber cells. And that's something that really only happens in the youth, or if you have cancer, or in some other rare instances, like with the use of steroids, or with some very extreme lifting, it might occur for short periods of time. But most of your muscle growth, almost all of it, is done via hypertrophy, okay? And hypertrophy is the opposite of atrophy. And atrophy is what occurs when your muscles do not get any exercise, which means that they break down. And when they do get exercised, hypertrophy is what occurs, and they get built up. So hypertrophy occurs when you exercise and stimulate anabolic processes, and muscle protein synthesis exceeds muscle protein breakdown due to work being done that had damaged the muscle tissue and it requiring physical adaptations. So muscle tissue is made up of many small muscle fibers. Those muscle fibers are not microscopic. You could see them if you were to look at one that had been biopsied from a human leg. And I actually have a diagram for you of what one muscle fiber consists of. You see, each muscle fiber is a cell that is made up of many smaller fibers. So I want you to start with this photo by looking at the upper right part of it, at the largest part, and then go down towards the lower left. And so notice the smaller and smaller units of the muscle fiber. And now on the smallest level, there are many tiny fibers that are called myofibrils. And it is the smallest filaments within the muscle fibers, called myofibrils, that contain the contractile tissue that does the work when you are lifting weights. And of course, as we all know, when you do work with that muscle tissue, micro tears are made to the fibers, which then get repaired and made bigger. But how is it that the muscle tissue actually contracts? Well, the muscle tissue contracts due to small units of what is called contractile tissue, called sarcomeres, which is actually the very smallest unit of muscle tissue that is so small it couldn't be pictured on that diagram in comparison to the larger fiber. And what these sarcomeres are made up of are very long, thin filaments of protein, specifically actin and myosin. And when your nervous system gives the signal to contract, these long, thin filaments will crawl up each other like that. All right, so that's why your muscle will expand and get bigger like that. All right, so first, this is actually what sarcomeres look like. So within all of the tiniest muscle fibers, this is what you would see if you looked at them under a microscope. So these lines that all run parallel to each other are the proteins that will slide up each other, right, and get more bunched up. These lines in between are holding them all together, okay? This is called an M line, this is called a Z line because of its zigzagging shape. So it's these long horizontal parallel lines that are actually doing the work of contracting and coming closer together. And then of course on the eccentric, sliding back apart, making the muscle longer. And this contractile work causes what is called contractile hypertrophy, which is a thickening of the muscle tissue by causing the muscle to grow in width rather than in length. This is because contractile hypertrophy causes a growth in the thickness of the muscle fibers by adding new myofibrils with new sarcomeres next to each other in parallel rather than in sequence. Okay, however, stretching is also hypertrophic and is another reason you should be doing it frequently. And so it can and does cause muscle growth because it applies tension to the muscle. However, it is not contractile hypertrophy. It is a different type of hypertrophy because you're not contracting the muscle under tension, you are stretching it under tension. Okay, so with stretching, you could actually be causing hypertrophy by the adding of sarcomeres in sequence. All right, and it's something that wouldn't be as hypertrophic or cause as much visible growth as the adding of sarcomeres in parallel, but it is still very useful, all right? And it's something that will contribute and put you above other athletes who, for instance, might not be stretching, all right? Think about it. If you are doing the same hypertrophy training as someone else, but you are stretching and they are not, so you are causing another totally different type of hypertrophy that they aren't causing, well, you are going to be more muscular than them. And I can guarantee that when it comes down to bodybuilding competitions, that kind of detail will make a difference, okay? But back to contractile hypertrophy. In causing it, it's important to know that different hypertrophic effects are caused by both the concentric and the eccentric portion of the movement. This is because when you apply a load or resistance to a muscle, causing tension while contracting it, it is a completely different physiological mechanism than when you are lowering a load and elongating the muscle under tension. And these two muscular functions are mechanically different enough from each other that they each have their own type of hypertrophy. So just as how picking something up and putting it down are two different things that have two different outcomes, they also are two different mechanisms in your muscle. And because of that, they each have their own hypertrophic processes associated with them. So it's so important to think of them as two parts of one movement and not ignore the eccentric and let the weight just drop back down as many people tend to do. All right, but the eccentric is actually more important than the concentric when it comes to hypertrophy. It has actually been found to be more hypertrophic when you are lowering the weight and stretching out the muscle under tension, because you are actually stronger doing this than bringing weight up. Okay, so you will actually be able to hold it longer and get more time under tension and really draw out the exercise more using that. Now, hypertrophy occurs to what is called the SAID principle, S-A-I-D, which stands for specific adaptation to imposed demand. You see, when the body is placed under stress or physical demand, the body will make specific adaptations needed for the demand being imposed so that it can meet the demand. And it will only make adaptations when there is a demand for them, because they are ergonomically expensive to make. All right, however, the greater the demand, the greater the adaptations. And the more specific the demand, the more specific the adaptations. Okay, that is why certain athletes who have done very specific training can do specific things that other athletes who haven't done that specific training cannot. So what you need to know is that hypertrophy is a physical adaptation that can be controlled and manipulated through specific imposed demands and manipulation of the training and training variables. Now, when your muscles are growing, it's not just due to an increase in the number of sarcomeres, because there is so much to your muscle tissue. So the growth is also due to an increase in the water and other fluid in the muscle, the nutrients being stored, and the number of muscle fibers, and even the size of the connective tissue that the muscle leads into. So now I'd like to direct your attention over here to the diagram of the muscle fiber cell that I have drawn for you here. So if you remember that diagram I showed you earlier that showed a breakdown in all of the smaller and smaller units of muscle fibers and filaments, this is the smallest unit. This is a muscle fiber cell, and this is a cross section of it. So if you were to slice it straight in half and look at it head on, this is what it's supposed to look like by my artistic rendition. Now, this is not, of course, to scale or anything, all right? So the ratios of the size of the myofibrils to the whole thing are not going to be accurate, all right? But what I'm trying to give you here is a visual representation of what the cell looks like and its two main big constituent parts. So here in blue are the myofibrils that I already taught you about. These are these small little filaments within the muscle fibers. And this red surrounding them is a fluid called sarcoplasm. All right, so that's where all of the water and nutrients and such is in the muscle cell. So I want you to really burn this into your brain and make sure you know what the difference between these two things are anatomically. And remember the word myofibril. Fibril is like the word fiber because these are the smallest types of little subfibers. And then plasm often refers to a fluid or gas. It actually technically means tissue, but it's used to refer to a lot of fluids, which is what it is referring to now. So remember that a muscle cell is made up of a bundle of myofibrils, which is then surrounded by sarcoplasm. Now, the myofibrils are actually bundles of what are called myofilaments. So they actually have even tinier filaments within them, and that is the contractile tissue that I taught you about here. Each muscle cell, like I have pictured there, contains many of these, all right, just innumerable. And these are the things that get torn apart and damaged when you are lifting weights to cause hypertrophy. Now, the sarcoplasm that surrounds the myofibrils is the fluid that contains the water and nutrients and energy sources for your muscles. So that includes ATP, glycogen, creatine phosphate, and many others. Now, you might have noticed that the prefix sarco appears in the word sarcoplasm as well as sarcomere. And that is because sarco is a prefix that means flesh. So the word sarcoplasm is a combination of a word that means flesh and a word that means tissue or fluid. And the sarcomeres are the actual contractile tissue that makes your muscles contract. And these are made up of both thick and thin filaments, okay? The thick ones are the blue, and those are made of the protein myosin, okay? And the thin ones are in red, and those are made of the protein actin.